Offlecture. Learn beyond class.
Hello friends, welcome back to Offlecture. Now we will look at the different types of fractions, that is proper, improper, mixed, like, unlike fractions, unit fractions and equivalent fractions. Each type has its own meaning, so let's understand them one by one. The first one is proper fraction. What is proper fraction? A proper fraction is one where the numerator is smaller than the denominator. A simple line definition will be the numerator is smaller than the denominator, then it will be known as proper fraction. The top number should be less than the bottom number, and the same is mentioned here. Okay. Its value will always be less than 1 whole. Why? You may ask why. Because making a full one needs all the parts. For example, let's say we have a circle and let's say we have 4 parts of it. 4 equal parts, 1, 2, 3 and 4. Okay. Now to make, let's suppose all parts are distributed like this. One second. If I separate these parts out, we will get 1, 2, 3 and 4. Okay. Now, because if we want to make it 1, it needs all the parts. It would need this also, this also, this also, this also. That is, if we want to make it a circle back, we need all its parts. With 3 parts only, we can't make a complete circle. That's why if we are using a proper fraction, it means the top part is lower than the bottom part, that is numerator is lower than or smaller than the denominator. Therefore, it will be always less than 1 whole. Okay. But here we take fewer parts than the total, so it will be less than a whole. Like, since in a proper fraction we take only a fewer parts, instead of taking all the parts, so it will be less than 4. Like you can see here, is it's 3/5. What it means is we have taken 3 parts out of all the 5 parts. Okay, that's why we are getting it as proper fraction which is less than 1. Okay, there can be other examples too, 1/2, 3/5, 7/8. Mostly you will see proper fractions only. The rule to remember for proper fractions is that proper fraction top will be smaller than the bottom. But now, since you know what is numerator and denominator is, you should always remember it like numerator will be smaller than denominator. Okay, and value is less than 1. For example, 3/5. And remember this note, a proper fraction never fills a whole. Part of a bar stays empty. That is, since it is a proper fraction and numerator is always less than denominator, so it will never fill the complete bar. Okay. Now let's understand with an example. What will be the example of it? Is 4/9 a proper fraction or not? We can check it step by step. First look at the fraction 4/9. Compare top and bottom 4 and 9. So we will write 4 here and 9 here. 4 is smaller than 9. Yes, smaller top means it's a proper fraction. So answer will be yes, 4/9 is a proper fraction because or as its value is less than 1. Or you can write because its value is less than 1. Okay. Now you guys try it. Pause the video and try this, that from this list, pick the proper fractions: 2 by 3, 7 by 4, 5 by 5, 1 by 6, and 9 by 8. Always remember the hint that top number should be strictly smaller than the bottom number. That is, numerator should strictly be smaller than the denominator. Okay. Pause the video, and then when you will resume the video, you will see the answer. So from here, what are the proper fractions? Proper fractions are 2 by 3, that is this one, and 1 by 6, that is this one. Why 7 by 4 is not a proper fraction? Because 7 is greater than 4. So definitely this will not be a proper fraction. Why 9 by 8 is not a proper fraction? Because 9 is not greater than 8. This is wrong. So this is also not a proper fraction. But let's say we talk about 5 by 5. 5 by 5 is nothing but equals to 1. Is nothing but equals to 1. It means that it is considering all the parts together. So will it be a proper fraction? Again, no. Because for being a proper fraction, always the numerator should be smaller than the denominator. Okay. So this is how we identify the proper fraction. Now let's move to second type of fraction, which is known as improper fraction. Now the case will be reverse. Here numerator will be bigger than or equal to the denominator. That is, numerator will be greater than or is equals to denominator. That then it will be known as improper fraction. And it can have the value 1 or more than 1. Okay, it can have the value 1 whole or more. You will ask why? Why it can have more than 1 or 1 whole? Because it takes denominator many parts to make 1 whole 1. So if the numerator is bigger than that, we have taken more than 1 whole, making the value more than 1, like 7 by 4. What it means is, let's suppose we know that this is the total number of equal parts of a particular object. So let's say we have a circle, we have 4 equal parts. So if it was 3 by 4, so it would look like this, which is a proper fraction. Okay. When we made it 4 by 4, 4 by 4, it means that all the parts. Okay. So 4 by 4 is nothing but 1 because it made complete whole 1. But now if we move further, let's say 5 by 4, it means that this is completely available, plus we have additional 1 extra piece. We have 1 extra piece. So this is 5 by 4. If we move to 6 by 4, it means we have 2 extra pieces. We have 2 extra pieces. And if we move till 7 by 4, it means we have 3 extra pieces. That's why the value of improper fraction can be 1 whole or more. Okay. This is how we understand the concept of improper fraction. And remember, improper fraction does not means it is wrong. Okay. Improper fraction does not means that the fraction is wrong. It is a normal correct fraction. It's a normal correct fraction, but improper in nature. Improper in nature. And the rule to remember for improper fraction is that the numerator will be greater than or equals to denominator. Either you can write like this, or you can write like numerator is greater than equals to denominator. Okay, example we have seen, which is 7 by 4. Let's go through an example. So how many holes in 7 by 4? It is asking us how many holes will be there in 7 by 4 fraction. So how we will do step by step? The fraction is 7 by 4. So each hole needs 4 quarters or 4 sections. It means that 7 quarters are 4 plus 3 quarters. 4 complete quarters like this, which will make one hole, and then 3 quarters more, which is this. So that is one whole and 3 by 4 left over. So if we asked how many holes are in 7 by 4 fraction, since 7 by 4 is an improper fraction, it equals to one whole, which is one complete circle, and 3 quarters from the another circle. Okay. Now you guys try it, that which of these are the improper fractions: 3 by 8, 9 by 5, 4 by 4, 2 by 7, and 11 by 6. And the hint is that in improper fraction, numerator will be always greater than equals to the denominator. So if you have to pause the video, try to identify, and then we will see its solution. So the answer is 9 by 5, or 9 over 5, 4 over 4, and 11 over 6. The reasoning is clear because 3 by 8 is a proper fraction. So it is not an improper fraction. 9 by 5 is a improper fraction because 9 is greater than 5. 4 by 4 is also an improper fraction because 4 is equals to 4. 2 by fraction is a proper fraction because 2 is not greater than 7. Okay, and 11 by 6 again is a proper fraction. Sorry, again is an improper fraction because 11 by 11 is greater than 6. So this is how we identify the proper and the improper fractions. Now let's move to the next part, which is mixed fractions. What is mixed fractions? A mixed fraction has a whole number and a proper fraction together, like 2 and 1 by 3. So a whole number and a proper fraction together make a mixed fraction, like 2, which is a whole number, and this part is the proper fraction. This is a proper fraction. So this makes it as a mixed fraction. Okay, we read it as 2 plus 1 by 3rd. Its other name is the mixed number. You can also say that it is a mixed number. Okay, why do we use it? Why there is a requirement to have a mixed fraction? Because 7 by 3, like improper fraction that we understood earlier, 7 by 3 tells you how big it is, but 2 and 1 by 3 tells you at once that there are 2 holes and a little more. So in everyday life, it is much easier to understand. Okay, when we discuss about improper fractions, we saw these kind of numbers, 7 by 3. So it is difficult to understand what is 7 by 3, like how we should interpret or how we understand 7 by 3. So the savior is mixed fraction. So how we can write this improper fraction into a mixed fraction? 2 plus 1 by 3. It means that we have two wholes plus a tiny part or a smaller part also, and we will read it as 2 and 1 by 3 like this, or 2 or 1 by 3rd. Okay, the structure is very simple. 2 1 by 3 is nothing but equals to 2 plus 1 by 3. It means that there are two wholes or two complete part and one tiny extra part also. Okay, and in the figure you can see we have two whole parts and 1/3 of another circle. Okay, so this is how we understand mixed fraction. Now let's do an example on it. This is, we have to write a mixed number which is 3 full pizzas plus half a pizza. So how we will do this? There are 3 whole pizzas, as we can see. There are 3 whole pizzas and one more pizza in which there is only half left, or half shaded. So how we will represent it as a mixed fraction? There are 3 whole parts and fraction part is 1 by 2. So we will write it together to be like 3 1 by 2 or 3 1 by 2, like this. We can write it as 3 and 1 half. Like if you want to say in text or in words, we will say it as 3 and 1 by half. Okay, let's now you guys try it. This example, you have 2 full water bottles and 3/4 of another. Write this as a mixed fraction and in words. So what is the hint for it? The whole number will come first and the leftover part will be a proper fraction, because mixed fraction definition says that there will be a whole number plus a proper fraction. Okay, so try this and then we will see its solution. So the solution is simple. We have 2 full water bottles. Plus we have 1 by 3/4 of another. 3/4 means, quarter means fourth part. Fourth part. So 3 by 4. So we will write it as 2 3 by 4 and we will read it as 2 and 3/4. And this will be our answer. Okay, I hope this is clear. Now we will move to the next concept, which is like fractions. Like fractions. Like fractions are those with the same denominator, that is, the bottom number is the same. In the fractions where we have the same denominator or the bottom number is same are known as like fractions. Like 2 by 7 or 5 by 7. 2 by 7 and 5 by 7 both have 7 as denominator, or bottom has 7 as denominator. So they are like fractions. Adding, subtracting, comparing them is the easiest. This is the easiest to compare two fractions. Okay, it is easiest to compare to these kind of like fractions. Why easiest? You will ask, like, why this is easiest to compare these kind of fractions? Because both have pieces of exactly the same size, so you can just count pieces. Okay, adds the top or compare them with no worry about the size. What it means is that both would have pieces of exactly same size. Both are having the pieces of exactly same size. Means that, let's suppose we have a roti. This roti has 7 parts of it. Okay, let's say we have 7 equal parts. Remember, 7 equal parts. So there are 4 parts to it. Okay, instead of circle, let's make it simple rectangle. Okay, so let's make it a rectangle, and it has 7 equal parts. 1, 2, 3, 4, 5 and 6. So there are 7 equal parts of it. So this is one chocolate bar, and we have another bar which is 1, 2, 3, 4, 5, 6 and 7. Okay, and it has also 7 equal parts. Both chocolates have 7 equal parts. Now if it is says that it is 2 by 7, it means 2 shaded regions, and it says 5 over 7, it means 5 shaded regions. So it is easier to compare that 2 by 7 is definitely lower than or smaller than 5 by 7. Okay, but we will understand it later, like how we can compare, add, subtract these kind of fractions. But just to know what is like fractions are those where the fraction has the same denominator, their parts are of same size, and examples can be 2 by 7 and 3 by 7. Okay, so the simple thumb rule will be, for like fractions we need same bottom, which is denominator. Okay, and remember that like fractions are easiest to add, subtract and compare. Okay, now let's move to the next part, that is the example of like fractions. Have to identify whether 3 by 8, 5 by 8 or 7 by 8 are like fractions or not. So we have to do it step by step. We have to look at 3 by 8, 5 by 8 and 7 by 8. We have to check each denominator. This is 8, this is also 8, this is also 8. So all three bottoms are 8. So same bottom means like fractions. So answer will be yes, 3 by 8, 5 by 8 and 7 by 8 are like fractions. Okay. Now you have to tell me, is from 1 by 5, 2 by 5, 3 by 5 and 4 by 5, 3 by 7 and 4 by 5, which are the like fractions and why? Pause the video, take the help of the hint, that is like fractions share the exact same denominator, and tell me that which of these 4 fractions are the like fractions. So answer is clear. 1 by 5, 2 by 5 and 4 by 5 are my like fractions because the denominator of 1 by 5, 2 by 5 and 4 by 5 are same. Okay, 3 by 7 is the odd one out. So this is not a like fraction. These three are the like fractions. Okay. Now let's move to the next part, which is unlike fractions. So unlike fractions means fractions with different denominators. Okay, we are not bothered about numerator right now. We are only bothered about denominators. So when you have same denominators, then you are having like fractions. But when you have different denominators, then you are having unlike fractions. Okay, so if you see the example of 2 by 3 and 4 by 5, these are unlike fractions. Before adding or comparing them, like if we talk about these unlike fractions, before we are adding or comparing these unlike fractions, we first need to make the denominators equal. we first need to make the denominators equal. Why is this needed? You may ask why there is a need to make the denominator equal, because their pieces are of different sizes. It is of different size and this is of different size. For example, let's say we have a chocolate bar which has three parts, three equal parts, which represents this, and there are two highlighted or shaded regions which makes is 2 over 3. Again, we have a chocolate bar, but now we have five equal parts of it. Okay, five equal parts of it, and out of this, there are four sections or four regions of shading. So here you can easily see, since their pieces are of different size like thirds and fifth, it is difficult to add and compare them directly, and if you do that it will be wrong. So we first have to change both in same size pieces. You can compare only when they will have same size pieces or the denominators are same. Okay, so the rule for unlike fractions are that their denominators will be different. You have to make them like first, that is, you have to make them like fractions. Now you have to identify out of these three examples, are these unlike fractions? Do they have different bottoms? So the first step is look at 1 by 2, 3 by 4 and 2 by 6. Check the bottoms. It is 2, it is 4 and it is 6. So all the bottoms are different? Yes. The answer is yes. So since all bottoms or all denominators are different, it means that they are unlike fractions. Now you guys have to try it. Sort into like and unlike fractions. A is equals to 3 by 8 and 5 by 8, and pair B is 1 by 3 and 1 by 4. So what you have to do is you have to sort them into like and unlike. Okay. The hint is same bottom means like and different bottom means unlike. So if we see the answer, pair A is a like fraction because 3 by 8 and 5 by 8 share the same bottoms, and pair B is unlike fraction because it is different 3 and 4. Okay, now let's understand fifth type of fraction, which is unit fractions. We have understood this unit fraction in the earlier classes also. So let's just revise here. A unit fraction has exactly 1 on the top, that is the numerator is exactly equals to 1, and it is written as 1 by n for any number of n except 0, except 0, because 1 by 0 means nothing. Okay, so in unit fraction, we understood this also, that a bigger denominator means a smaller unit fraction. That means that if it is 1 by 2 or 1 over 3 and or 1 over 4, 1 by 2, that is half, will be greater than 1/3, which will be greater than 1/4 or 1/4. And the reason for this is, we know that because the more parts you split one thing into, the smaller each part will become. That is, sharing, let's say, a pizza among three equal parts. So this part will be definitely greater than the pizza that has been shared into 8 equal parts. Okay. So 1 by 3 will be greater than 1 by 8. So remember, bigger denominator means a smaller unit fraction. Okay. Let's do a simple example on it. Let's say we are having three fractions. We have to identify which are the unit fractions. We have 1 by 4, 3 by 4 and 1 by 9. So we have to look at the fractions. A unit fraction has 1 on the top. So 1 by 4 and 1 by 9 has 1 on the top. While if we talk about 3 by 4, it doesn't have 1 on the top. So it is not a unit fraction. So answer will be unit fractions here are 1 by 4 and 1 by 9. Now you guys have to try it. Pause the video and write the unit fraction for one part of the cake cut into 7 equal pieces. Then say which is bigger, 1 by 7 or 1 by 12. Okay. You have to write the unit fraction where a cake has been cut into 7 equal pieces, and you have to identify which part is bigger, 1 by 7 or 1 by 12. So if we do it step by step, we will know that if a cake is being cut into 7 equal parts, so one part or unit fraction will be 1 by 7. Okay. And if we want to compare it with 1 by 12, as we know that if denominator is higher, it means the fraction is lower. So 1 by 7 will be greater than 1 by 12, or 1 by 7 is bigger than 1 by 12. That is, fewer parts means larger pieces. Okay. Now let's move to another type of fractions, which is known as equivalent fractions. So equivalent fractions look different but have the same value. They are different fractions that show the same amount. That is, like 1 by 2 is equals to 2 by 4, or which is equals to 4 by 8. They land at the same spot on the number line. We make them by multiplying or dividing the top and bottom by the same number. Okay. They sit on the same spot on the number line. Like if you want to point the fraction on the number line, they will come and sit on the same number, because what we are doing is we are making them by just multiplying or dividing the same part from the numerator as well as from the denominator. Now you may ask the question, why does the value remains the same? Why does the value remains the same? Because multiplying both by the same number just cut the pieces smaller while taking proportionally more. That is, the total amount remains unchanged. For example, let's say if we talk about this pizza, and what we have done is we have cut into 2 pieces, 2 equal parts. So my fraction will be 1 by 2, and this shaded area is representing this 1 by 2, that is half. Okay. Now let's say we have the same pizza and we have made 4 equal parts of it, 1, 2, 3 and 4, and again we shaded 2 parts of it. So if you see, and if you write the fraction for this is equals to 2, because there are 2 parts of shading, by total number of parts, which is 4. But if you see visually, this area and this area is same. Okay. It means that 1 by 2 is equals to 2 by 4. So same amount has been shaded in both the pizzas. So 1 by 2 is equals to 2 by 4. And how we reach from 1 by 2 to 2 by 4? If you just multiply 2 on the top and 2 on the bottom, we will get 2 by 4. Multiplying numerator and denominator with the same number is nothing but multiplying with 1 only, because 2 and 2 get cancelled and will give you 1. So it doesn't matter if we are multiplying or dividing both numerators and denominators by the same number, and if you just multiply or divide it, you will get your equivalent fractions. Okay. Like cutting For example, one more example you can think of is like cutting a half roti into two pieces. Now there are two pieces, but it is still the same amount of roti. Okay. So equivalent fractions look different, but are worth exactly the same. Let's understand with an example. What we have to do is we have to make a fraction equal to 1 by 3. Okay, so we will start with 1 by 3. Let's suppose this is 1 by 3 and we want to make a fraction equal to 1 by 3. That is, we want to identify the equivalent fraction of 1 by 3. Then let's multiply it by 2 at numerator and denominator. So 1 by 3 multiplied by 2 here and multiplied by 2 here will give you 2 by 6. What it means is that we have made 6 equal parts of the pizza or the circle, and we have shaded the same amount of area, or we have shaded the same amount of size of the pizza. So this becomes your equivalent fraction, that is 1 by 3 is equals to 2 by 6. Let's suppose if you multiply 1 by 3 with 3, let's say 3 here and 3 here, so you will get 3 by 9. This is also an equivalent fraction of 1 by 3. You can multiply with any number and that will be your equivalent fraction. Even if you multiply it by 4, you will get same 4 by 12, which is also the equivalent fraction of 1 by 3. For example, 5 by 15 is also an equivalent fraction, because if you divide it by 5 and this also if you divide it by 5, that is numerator and denominator both are divided by 5, you will get 1 by 3 only. So all these are the equivalent fractions of 1 by 3. Okay. Now you guys try this. Write two fractions equivalent to 2 by 5 by multiplying the top and bottom, that is numerator and denominator, by 2 and by 3. Okay. The hint is that the multiplication to the top and the bottom by the same number each time. So it will give you the equivalent fraction. Pause the video and then we will see the solution of it. So if I take my fraction 2 by 5 and if I multiply it by 2 here and multiply by 2 here, we will get 4 by 10. We will get 4 by 10. 2 by 5 multiplied by 2, and this is also multiplied by 2, we will get 4 by 10, which is the equivalent fraction of 2 by 5. Similarly, if we take 2 by 5 and multiply it by 3 and also here we multiply it by 3, we will get 6 by 15, which is also the equivalent fraction of 2 by 5. So this is my answer, 4 by 10 and 6 by 50. Okay. So in the types of fraction, we discuss about 6 type of fractions. One is proper fraction. The proper fraction is where the numerator or the top is smaller than the denominator, which is bottom, and value will always come less than 1. Second was improper fraction, where the numerator is greater than equals to the denominator and it has value 1 or more. Then we discuss about mixed fraction, that is a whole number plus a proper fraction, that is 2 1 by 3, which means nothing but two parts which are whole and then a proper fraction. Then we discuss like and unlike fractions, that is if the denominator is same, then we say it's a like fraction, and if the denominator is different, then we say it's an unlike fraction. Then comes the fifth part, that is numerator is equals to 1. Numerator is equals to 1, which is known as unit fraction, Okay. And then comes the last part, which is equivalent fraction, where the looks is different, but they point to the same value on the number line. For example, 1/2 and 2/4 are the equivalent fractions, because if you multiply 1 and 2 both by 2, you will get 2/4 only. So they are equivalent fractions. Okay. Next up, we will discuss how we represent fractions on the number line in the topic 3. Till then, goodbye. Enjoy.